Hello again. So let us look at our discussion on data types. This is lecture 3. So in the lecture 2 we discussed all of this. So hopefully by now you've gone through the lecture 2. Let us define some variable names. Okay. Why these variables are required, etc. We'll see that later. So suppose if I now want to declare an integer, I will just say a. So here in this we are not bothered about int as of now because that is called a data type. We'll only worry about a, which means, for example, when I said int, right, int is recognized by the language because it is a keyword. Similarly, when I say hash include, it is recognized by the preprocessor, right, but it is not a keyword. Let us see that. Alright, which means, for example, if I now want to declare, this is my variable name. Now in this case a is my variable name. Okay, which means if I say int a and a, let me say a equal to 10. As of now let us not worry about that, and a equal to 5, right? And let me just display the value of these two. Don't worry about this printf statement and the switches that I am using. As of now you can just listen to the lecture. So when we look at format specifier in the subsequent lectures, you will be able to understand what I just did. As of now we'll just use this statement to print the value of a. So just follow the syntax. So now I will say a and a. Alright, so I have two identifiers called a and a capital A. Alright, so let me submit this, save this program and compile this program. So I'll do the GCC, okay, and then do the output. So if you now see, my a is equal to, if you see here, my a is equal to 5, this is a is equal to 5, my a is equal to 10. So that is why a is different from a. So a here is a variable name again. Okay, so a is a variable name again. Okay, but it is case sensitive. Even if I had two a's, it is able to differentiate. Okay, so this is what I mean by variable. Now suppose if I have let me have a lengthy variable name. Okay, so let me just see lengthy variable name, and let me save this and let us try and compile this. Okay, it has no problem as long as you are able to remember this. Okay, but normally it is 32 because after 32 it ignores remaining everything. So you should not have a very lengthy name. Okay, number one. Now I also said in the lecture 2 that suppose if I want to have a variable name as one of the keywords itself. So let me say I want to do something called int float, where float is a keyword. So when I try and submit this to the compiler, the compiler typically, okay, what it does is something like this. Okay, so what the compiler typically does is, I compile this, it says two or more data types in the declarer specifier float, isn't it? So which means that float is again data type. So it gives a warning. We look at the difference between warning as well as declaration, but this is an error. So it does not allow me to compile further. So which means a variable name cannot be a keyword. Alright. Now suppose if I start my variable name with something like that. Suppose if I do it as a capital float, for example. Okay. Now this should be allowed because my capital float is different from small float, because all keywords are lowercase in lowercase. So a capital float is different. So we should definitely try and avoid something like this, but this doesn't give me an error. For example, if I start with say 1a b, this is my variable name, because now I have started with what? I have started with a digit. Okay, so when I want to compile this, so it's again an error because it takes it as invalid suffix on an integer constant, which means it cannot be a variable, cannot be a keyword. So normally it is taken as a constant, but the grammar typically says that this should not be a non-alphabet. For example, suppose if I have an underscore, now this is my underscore, right? A variable can start with an underscore, right? With an underscore. So when I do something like this, the variable starts with an underscore. So let me save this code and try and compile and see if it gives any error. No problem, because I have an underscore, right? So normally underscore is used for some built-in macros or some language defined standard identifiers. Okay. Now there is one more issue that we need to look at. Suppose if I now declare include as say 1000, and now I want to see what is the value of include. I will say include equal to include. So if it doesn't allow me to declare that, if it gives me an error, then I know that it is a keyword or it is defined by the language, so I am not supposed to modify it. So let us just see. Now I don't think there is any problem with this. See, my include is equal to 1000, so which clearly means that include is not a keyword, right? Okay. Now let me take printf itself. So for example, let me now do printf. Okay. Now if I say printf equal to 9000, right, and there will be an issue now. Now suppose if I say printf equal to printf, for example, all right, I say printf equal to printf here. Now I save this code here, right, and then if I compile this, okay, I have no issue with the printf, right? It says built-in function print, it's a warning. Okay, built-in function is defined as what is called is declared as a non, but that's fine, warning is fine. But this error is totally different because it is I am redefining printf here. So what we will do is we will just try and take this printf maybe after probably this. Okay. Now when I do something like this, okay, right, I will never be able to, for example, let me remove this and try and take printf down. Okay, now if I do something like this and try and run this code, right, it says error, object called printf is not a function or function pointer. Okay, no printf declared here. So what I will do is I will comment this, right, I'll just comment this and let me just see what happens now. So we are just trying to understanding these errors, See, now we have no problem, it works, right, which means that printf is not a keyword, right? Then what is this printf? Even if printf is not a keyword, it is taken as a standard identifier. So if I declare printf here, printf is a standard identifier. Okay, hence can be redefined. All right, which means hence can be redefined. So keywords cannot be redefined and standard identifiers can be redefined. Okay, this is what it actually means. Now we should we have to identify what is a standard identifier, what is not, what is a keyword. For example, we know int is a keyword, so that's why we can't say int. What about main? Okay, main is so main. So let us try and redefine main now. So let me take this fellow above. Okay, so maybe I'll take this fellow above main. Okay. Okay, so now let me take this hash include above. We have seen all of this, so we will comment printf because we will be having problem with printf later. So now if can I redefine main, that's what it actually means. So if for example, can I say now main equal to 9000. You see, main, again I am doing that. So main is a standard identifier, which means it can be redefined. Alright, which means main can be redefined. What does that actually mean? Let us see whether it is allowed. Okay, so it says error, because again we have said previous declaration of main was here, so it is now taking main as this and this, it is taking a redeclaration. Let us see, can we make it as a inside the scope? We will not worry about, don't worry about scope and all that. Okay, so let us see how far this protects main. Now it is not a problem if you just see, isn't it? So my main is equal to 9000, which clearly means that main is a standard identifier which can be redefined. That's what it actually means. Okay, so this is what we mean by this lecture was all about variable names and the restrictions on the variable names and no restrictions on the variable names. Alright, next in the coming lectures. Alright, thank you very much.